Dear students, welcome to the next chapter, which is about the Internet. You all know the Internet, do you? So, what is the Internet? And what is not the Internet? I will give a brief history why the Internet was developed and what kind of ideas are behind it. We will compare it with what you have learned last week about networks, computer networks, and see what kind of special implementation have been implemented in the Internet. Why is the Internet so successful, and actually is it successful? And the final question will be more business oriented. Why is the Internet important for companies? So let's start with the question, what is it Internet and what is it not? Is the Internet a cloud? Sometimes it's visualized as a cloud. In diagrams you see somehow a cloud where all computers are connected to. In the end, it simply means a cloud is somehow foggy, you do not know the borders really, you do not know the inside, and for most of the people that's how the Internet looks like. We do have our client to the Internet, a laptop, a computer or a smartphone, but the internal things in the Internet we don't see, we aren't aware of, and sometimes we're not really interested in. And that's okay if we simply would like to use the Internet. Is the Internet and the World Wide Web the same? Actually, it's not. The Internet, or at least its predecessors, have been developed in the late 60s or beginning of the 70s, whereas the World Wide Web goes back to the 90s. But the World Wide Web is the interface to the Internet right now. So most of us simply open up a browser if we would like to access the Internet. But in the end, it is like in the computer, you have windows and you have browsers and so on. And as windows form the user interface to the computer nowadays, so the World Wide Web does it to the Internet. So for many people, World Wide Web and the Internet are the same. Technically, it's not. Is email part of the Internet? Actually, email is only one of the applications in the Internet. Like, for example, the World Wide Web. We will have a closer look on these applications if we go a little bit more detailed into techniques. On the right side, you can see a picture of the Internet, which I've taken from Wikipedia. So what you can see is that you have a network which has lots of connections and links and things which are connected. And actually, the Internet is meanwhile so big that really many computers and other devices are connected. Let's have a look at the end of the 50s, beginning of the 60s. We have our mainframes and mini-computers, and several terminals are connected to one mainframe or mini-computer. Later on, several computers are connected to local networks. However, as you might remember, at this point in time, if you decide to go for IBM, if you buy a computer, you have to go for IBM when it comes to printers and so on and so on. And each company, like IBM, develops its own type of networks. This is visualized in the networks you see below. We have used different topologies like a ring, like a star, like a tree, or like a line. And these shall simply represent different type of networks. And these networks haven't been really compatible to each other. So if you would like to connect these networks, something like a network between other networks is required. A network internetworks. And this is actually where the name Internet comes from. The Internet is nothing else but a network, inter-networks. There is one more thing to mention, not only a network between networks. In the 50s and the 60s there was a Cold War. That is, there was a strong competition between the Western world, led by the US, and the Eastern, led by the Soviet Union. And there was some hard military competition. And not only the US, but the Soviet Union was able to develop nuclear weapons. And at this point in time, the Department of Defense were thinking about strategies, and they were taking some kind of risk analysis. And they realized that the communication systems we have had in the West, they have had in the US, was quite vulnerable. It was a centralized system, and if you have a centralized system, then you just have to destroy the center and the complete system is not able to work anymore. So the idea was to have a decentralized system, decentralized technology, decentralized network architecture, but as well a decentralized organizational structure. Think about yourself. Who owns the Internet? Who defines the laws, rules and regulations in the Internet? Is it the US? Is it a company like Google or Microsoft? Actually, it's hard to answer these questions. It's not a simple question. If the network would be centrally organized, then you simply destroy the central organization and the network wouldn't work any longer. So no, Google doesn't own the Internet, nor does Microsoft, nor does the US, nor is it the UN. And this kind of robustness of this decentralized technology leads to some problems we are facing right now. For example, if you think about criminality in the Internet, it is very tough to get it away, to sort it out, because there is no, let's say, central police agency in the Internet who could fight it. The Internet is simply an infrastructure which is decentralized, and that makes it very hard to get control over it. But that has been the idea from the very beginning. Decentralized networks have advantages over centralized networks, at least when it comes to robustness. If you compare, for example, today's energy networks, then these are mostly centralized. We have big power plants, power stations, and in the future we would like to have more decentralized ones which have lots of sources of energy, like solar energy, like wind energy and some other forms of energy. We are now in October 2022, and at the very beginning of this month, 2 central cables of the Deutsche Bundesbahn have been cut. The complete railway traffic in northern Germany was going down. And what you can see from this example is simply central components lead to vulnerable systems. So decentralized systems usually mean there's more robustness. Let's briefly step through the last decades and check how the Internet has evolved. Again, in the 50s we have these centralized telephone networks which was recognized as a risky one. In the 60s, as an answer to this risk analysis, the ARPANET has been developed. This was a decentralized network. However, it was not well suited to interconnect other local networks. This was possible in the 70s when this TCP/IP stack had been developed. At this point in time, it was mostly universities with several computers which were connected to this Internet. And the first applications have been developed at this point in time. Email, news, file transfer protocol, And news, that's something like forums, like these virtual blackboards where you can start threads and start discussions which are open for everybody. In the 80s, the internet grew and more in universities were connected, and it was quite successful in a way. And the government decided to no longer be the owner of the internet. So it was privatized, and first internet service providers like American Online popped up. But it really started then only in the 90s. Why? Because at this point in time the World Wide Web was developed. Before that, it was mostly engineers and computer scientists who used the internet for communication. It was quite complex, so you had to type in commands and things like that. But now we had Windows, we had the mouse, and we had these browsers, and now everybody was more or less able to handle this kind of communication. By the end of the decade, by the beginning of 2000, there was this dot-com bubble which then imploded. Many companies went down. Only the ones which had a real good business idea like Amazon or Google, these ones survived. In 2005, this term Web 2.0 popped up. So what's that? Web 2.0 is no, let's say, new hardware or no new protocol. It's more a cultural thing. Before that, there was, like in the TV or radio, there was big stations which developed content, and there were many readers who read it. But this changed. You can see, for example, the pop-up of social networks in this point of time. So in this kind of social networks, there is not one author, but everybody is an author. Or Wikipedia. If you compare Wikipedia with, for example, these British encyclopedia, then these encyclopedia have always been written by a few wise men and women. However, the Wikipedia was, in the end, a source of knowledge developed by everybody. So Web 2.0 means everybody can participate. You're not only a reader, you're a writer as well. But how does the internet look like today? There are some evolutions which are worth to discuss. First of all, let's have a look on Internet of Things, IoT. As you know, it's no longer only computers and smartphones which are connected to the internet. So are machines, cars, TVs, cameras, and so on. But what does it mean? If we face viruses or attacks through the internet, then not only computers, but machines, cars, and so on are in danger. So looking back at the very beginning of the internet, where we wanted to have a robust network, then we must see from security and communication we are now going to insecurity of everything. Just have a look on the discussions right now where we face risks on our infrastructure in Europe, in Germany, when it comes to invasions in the internet through Russia and other countries. At the very beginning, there was a hope in the internet that we can guarantee free speech and that suppression was no longer possible due to the fact that the internet was an infrastructure everybody could use. And this was really the case in the 80s and 90s and maybe even in the beginning of the 2000s. But nowadays things have changed. Latest since Edward Snowden, who was employed at the NSA, the National Security Agency in the US. Latest since he has published what kind of tools are used to intercept people, not only in the US but on the whole earth. Latest then, we know that the internet has changed and is now a means for surveillance. Besides surveillance, another aspect pops up. We are living in a world of fake news, lies, manipulation and disinformation. Everybody can put every nonsense into the internet. Just remember, the internet is decentralized and robust, so it's very hard to simply pretend somebody from publishing some kind of information. Think about Corona. Think about the fake news about stolen election in the US in 2020. Or think about Pizzagate in 2016. The big companies in the internet, the social networks, they really compete on the attention of their users. I can really recommend the movie The Social Dilemma, which is published on Netflix. And you see quotes here from experts who are arguing that fake news spread 6 times faster than true news. The internet was a network for information where, if you think about World Wide Web 2.0, information could be delivered by everybody. But nowadays we have to face an information overload or even a disinformation. And one of the biggest challenges for the future will be to simply agree about what is real and what is not real, what is real and what is fake. Finally, the internet has become omnipresent. In the past, there has been a clear distinction between the real world and the virtual world. But today, the line between those two are getting more and more indistinct. Another fact is the internet becomes more and more commercial, which leads to discussions about net neutrality. Just have a look in Wikipedia or any other source what this is all about and why this is important for the internet and why it is under risk. And there are trends which will continue. Big data, cloud computing, artificial intelligence or machine learning. Just based on the fact that we store more and more data in the internet, these things will become possible. Again, have a look on the beginning of the internet in the lower left corner. You see there is only computers which are somehow connected by this inter-network. And on the other hand, on the other side, you face now the new networks, the new internet. You see smart energy, smart health, smart cities, and so on and so on. And all these are based on Internet of Things. So there are billions, really billions of sensors and actuators which are controlled by the internet. So it's no longer only computer, it's our real life which is influenced by the internet. Let's have a look on the quantitative evolution of domains and users within the internet. Let's first have a look on the upper right corner on this diagram, user of the internet worldwide in million of users. So what you can see is a constant trend starting in the 2005, at least that's where the measurement started, going to 2021, 22, and you see that roughly 5 billion people worldwide are connected to the internet. If you go down then, you see the same numbers for the user of the internet in Germany. We are now facing roughly nearly 70 million people connected to the internet in Germany. And if you say there's 80 million people in Germany and the very oldest one and the very youngest one are not able to handle the internet, then you can see that we have a nearly 100% penetration. It means everybody in the internet who is able to handle the internet is in the internet. Another way to sketch the size of the internet is to see how many web servers or top-level domains in top-level domains are available. So we will talk a little bit later about domains and top-level domains, but I guess you have an intuitive understanding what this is all about. So how many domains are registered, for example, in these .com top-level domains? There is more than 160 million addresses ending with .com. This is really a big amount of domains. In Germany, you can see the figures in the lower left corner, and you can see that roughly from 2014 onwards, this number is not really increasing anymore. Let's have a first summary. Literally spoken, the internet is a network between networks. So in the past, different local network technologies were interconnected by one global network. It is important to understand that the internet has a decentralized architecture and a decentralized organization. This decentralization leads to robustness, but it leads as well to the fact that it's very hard to control the internet. The internet has continuously grown in the past decades. Meanwhile, more than 1 billion computers are connected to it. Half of the people on Earth are online. However, the internet has changed its character in parallel. So it leads to more insecureness, it leads to surveillance, it leads to manipulation. So in principle, the internet passes through continuous change. The internet is based on a layered architecture. You should be familiar with the following figure, which is a simplified layered architecture. You can see the internet layers in the middle, TCP/IP. We have the network layer at the bottom with radio networks and cable-based networks like Ethernet, UMTS, ATM and so on. And we have the application layer on top, where we see applications like email, World Wide Web, voice over IP, chat and so on and so on. Again, we have these advantages. Single components can easily be exchanged or added. We have independent development. Remember, we have a decentralized network. Nobody owns the internet. Nobody can really control the internet. And by having this layered architecture, these things go hand in hand. You could develop and implement a new software which might be better than the existing one, and by that you create a new brick which could exchange or replace an existing brick in these simplified layered architectures. And if it is good, and if your innovation is highly accepted, then in the end it will be part of the internet. It's not that any kind of organization or big company has to support it. It is something which somehow develops and is not controlled really by anybody. In the chapter about computer networks, we argued that each computer connected to a network requires a unique address. So what is the address of your computer if you are connected to the internet? Actually, we are having two addresses in the internet. There's first the IP address. IP stands for Internet Protocol, which is good for computers. It consists simply of numbers, but it's not so good for people because it's like a telephone number. It's hard to remember. We will discuss about IP addresses later. And then there is a domain address, which is good for people. Both addresses are sometimes called internet address, which of course is misleading. So better ask twice which address is really meant. Let's have a look at the hierarchical structure of the internet address. You can compare it with a telephone number. Let's first have a look on the telephone to better understand the internet address later on. When you have a telephone number, you have first an international prefix, which is +49 for Germany. Then usually you have a national prefix. Aachen has the 241. And then within Aachen, the FH Aachen has the number 6009. And finally we have an extension within the FH Aachen, which is my number in my office. And it's not only the number which is hierarchically, it is the way it is organized, which is hierarchically again. So there is an international committee who decides which prefix go to which country. But this hands over the responsibility for national prefixes to a German institution, which has been the Deutsche Bundespost in the 40s and 50s, who decided which national prefix goes to which city. And again, there is a local post office who assigns these 6009 to the FH Aachen. But then the extension is decided by one person who is responsible for telephone numbers at the FH Aachen. So you can see a hierarchy in the organization as well. And that's actually the same when it comes to the internet. We have a top-level domain, .de for Germany, which is assigned by one central organization, namely the ICANN. Within Germany, then the DENIC, another organization, hands out domains within the .de top-level domain. So you have to apply for it, you have to register your domain, and then you can get it. Within this domain, somebody at the FH Aachen decided about the subdomain Wirtschaft, business, and within our department, somebody decided to go for the address www, which is then a third level domain address, fourth level domain address. And hierarchies can have even more levels. Let's once again have a look on it. We do have this internet root domain, which is simply a dot and which never shows up in any kind of address. But then we have these, what it's called, top-level domain. DE stands for Germany, and we have second-level domains within, like FH Aachen, and we have third-level domains and maybe even fourth-level domains. So you can see this wirtschaft.fh-aachen.de is finally assigned to a computer. So what kind of top-level domains do exist? How many do you know? At the very beginning, there were just a few top-level domains which are called the general top-level domains, like .com, .edu, .gov, and so on. Com stands for commercial, edu stands for education, so each and every school or university in the US is assigned to a top-level domain edu. Gov stands for government, so basically all administration organizations like the White House are assigned to a gov top-level domain. Mil is military, net is network, so all our kind of organizations which have to do with the internet are assigned to .net. And finally there's org, which is for non-profit organizations like, for example, Wikipedia or Amnesty International. It turned out that the management and the assignment of domains within these top-level domains, it was a little bit tricky if you do it worldwide. So later on, country-specific top-level domains were added. You have DE for Germany, UK for United Kingdom. You have US for United States, however, it's hardly ever used. And some countries simply had luck. You know this top-level domain TV? Probably you know it from Apple TV or Borussia Dortmund TV or something like that. Of course, TV usually stands for television, but when it comes to a top-level domain, it's Tuvalu, which is a small island in the Pacific Ocean. The same is true for FM, which is Federation of Micronesia, which is in the Pacifics as well. And FM, you maybe know it, is this radio band which is used in several countries. So if you have a radio station, the FM top level domain is well suited for you. And countries like Tuvalu make really a big amount of their yearly income by selling or by renting their top level domains. Decentral organization, here we have it again. There is not one organization which assigns top level domains. There is each country assigns subdomains according to its own rules. In the past years, additional top level domains have been published. Info, name, museum, and there are some more to be added or which have been added in the recent years, like NRW, Köln, shop, Zara, hotel, and so on and so on. So at the very beginning, people have been skeptic how robust would be as an internet be if you have too many top level domains. So there we're not really going, let's say, more than a few hundred, 200. That's what we have, and we have country specific top level domains. Now we have experienced that the internet is capable of handling several thousands top level domains, so more and more are popping up. Unlike telephone numbers, at least in Germany, the internet addresses have an inherent value. For example, if you have this internet address pizza.com, probably there are many people who are hungry for a pizza who simply type it in. And if you do not have an address with pizza in its name, then it will be probably a little bit problematic to get the people into your internet account. Once again, think about addresses. So if you think about the White House in Washington, which is the correct address for those ones which are given in here? Of course, it's whitehouse.gov, because gov is a top level domain for all these administrative organizations. However, a strategy could be and has been to use similar addresses, like for example whitehouse.com. So you can try to use those addresses to simply get people who have typed in the wrong address at the very beginning. You can see the most expensive domains in 2014 and today. So things like sex.com, porn.com, they simply emphasize that sex sells. And if you look on today, then the most expensive domains, at least for those ones which have been sold in 2020, have been oa.com or it.co.uk, but the prices have gone down. So if you get $200,000 in 2020, you make a good deal. In 2015, up to 12 million have been paid for addresses. I already mentioned the IP address, which is the address which is better usable by the computer. So how does this look like? Currently, we are using IP version 4 and IP version 6 in parallel. So first I introduce this IP version 4. Each IP address consists of 32 bits, that's equal to 4 bytes. And each of these IP addresses identifies one computer connected to the internet, or more exactly one interface of a computer. So if you, for example, are connected with your smartphone both to the mobile internet over LTE, for example, and to the Wi-Fi, then at this point in time you have two different IP addresses. The addresses are typically given in the what is called dotted decimal notation. So you have for each byte one number, which goes from 0 to 255. Why that? Because 0 to 255 are 256 numbers, which is the same to 2 by the power of 8. In total, we have then two by the power of 32 addresses, which is roughly 4.3 billion. These IP addresses are administered by the ICANN, one of the few central organizations. Advantage again for the IP addresses is they are easily handleable for computers because these bits can easily be processed. The disadvantage is it's not user-friendly. So it's like telephone numbers. Just think about how many telephone numbers you know by yourself, not looking up, and how many internet domain addresses you know. And you see it's a very big difference. So are these 4.3 billion addresses enough? On the one hand, the idea has probably been there's roughly 4 billion people on the earth. So if each and everybody should have one computer, the number of IP addresses is sufficient. But there are a few problems. First, IP addresses are sold blockwise. So for example, the FA Aachen requires more than 256 addresses. So they had to buy 65,000. So it's called a B network within these IP address ranges. And now many of these addresses are unused. And in addition, you faced the fact that we have IoT, that not only computers and smartphones are connected to the internet, but that there are toasters and coffee machines and fridges and cars connected to the internet. So we are running out of IP addresses. That's why IP version 6 has been introduced a few years before. It has not a 32-bit address, but 128 bits. It's represented in a different way, 8 blocks of 4 hex digits. So an example of an address could be 1, 2, 3, 4, 5, 6, 7, 8, and so on and so on. Just think about how many things can be assigned with an address of IP version 6. Now we have two addresses, the domain address and the IP address. So which of those is really used? Both are used, but there is this domain name system, or in brief DNS, which assigns both addresses to each other. Actually, it's a big database which looks like a telephone book. So you have two columns. On the one hand, you have the IP addresses, and on the other hand, you have the domain addresses. Each time you enter a domain address, for example, into your email program, then first the email program connects to the DNS and asks for the corresponding IP address to the given domain address. And then it starts to communicate using this IP address. So in the end, when communicating in the internet, it's always the IP address which is used. If there would not be any IP address, you could not communicate. If there would not be a domain address, you could communicate. However, it would be necessary to know and handle all the IP addresses by yourself. If you would like to look up a certain IP address corresponding to a domain address, you can go, for example, to ping.eu, which is a web page which simply hands out this kind of information. I already mentioned the ICANN, which is some kind of central organization to assign top-level domains or handle the IP addresses. So once again the questions: who owns the internet? Who decides on rules? Like, for example, IP version 4 or IP version 6. The internet does not have a real government. It's not the UN, it's not any kind of country, it's not any kind of company. However, there are certain rules which are used worldwide and which have to be continuously developed in different boards and committees. And there are a few important but small players like IETF, W3C, ICANN, IANA, and so on. These are relatively small organizations, I think all hosted in the US, but it's not that they're regulated by the US. So in principle, these organizations try to have as little as possible or necessary power just to keep this internet a decentral organization as far as possible. If you look on the quantitative development of the internet, you can see it is really a success story. But what are the factors which make the internet so successful? 4 of those factors I have identified. First, as mentioned before, there's the layered architecture. This enables a very fast development. So new things which are better, new protocols which are better, new applications which are better, are simply taking over. Second, it's an end-to-end architecture. So if you write an email or if you browse through the internet, then you just need to have the address of the web server or the email server, and the rest is fine. So if you send an email, for example, to the US, you don't have to care which way it goes. If it goes through a satellite or to a fiber link through the ocean, this is done by the internet as such. If you compare it for example, a car, then you have to make yourself aware of the way from, for example, Aachen to Berlin. You have to decide at each crossroad if you have to go left or right. Nowadays, if you have a navigational system, you could argue cars have become an end-to-end architecture as well. One of those things which are really surprising is the scalability of the internet. So what does scalability mean? Scalability means something is robust against growth. For example, take a class you are in the university. So it works if you have, let's say, 100 students in the classroom. And if you say it is quite successful, you could go into a bigger class, so we have maybe 200 or 400 people in there. Maybe you could, let's say, make a copy and send a video to a third or second or a third classroom and go up for, let's say, 1,000 students which are taught at the same time. But to think about 100,000 or 1,000,000 students, you see it's not working anymore. So when you talk about classes, you have maybe a scale from 10 to 1,000 where somehow the same principles work. If you compare the internet, then the internet started with its architecture with, let's say, 100 computers, but now we are talking about billions of devices which are connected to it. And the principal structure is still fine. It's still the same. But you have other dimensions of growth. Not only the number of connected devices, but the amount of bits and bytes which are transferred. And of course, these ones have exploded as well. And you have another perspective, which is the way the internet is used. So first only emails and ASCII news, nowadays audio, video and control of machines and so on. And even in this perspective, the whole internet is scalable. Last but not least, we have this distribution principle, distribution development, decentralized control. And beside a few exceptions, for example, the definition of IP address, the internet is not controlled from any kind of central position. This makes it a robust network, but this makes it a network which is hard to control when you talk about, for example, from manipulation or other things like that. Let's have a second summary. From a technical perspective, the Internet is based on the TCP/IP stack. On top of TCP/IP, different applications or services are offered, and below TCP/IP, the Internet is based on different technologies, wireline or wireless. We have two address schemes in the Internet, domain addresses and IP addresses. Both addresses are used and they are assigned to each other by DNS. The Internet is decentral, both from an organizational and from a technological perspective. And finally, there are four factors Internet's success is built upon: layered architecture, end-to-end architecture, scalability, and decentralization. Why do you use the Internet? Why do billions of people use the Internet? The Internet as such has no added value. Nobody likes to go for a network. The Internet creates benefits through its applications and services. Killer applications in the past have been, for example, email, World Wide Web, social networks, or when it comes to mobile Internet, WhatsApp. But what are these applications? If you once again take a look on this layered architecture, it's actually just a program which defines maybe a new kind of protocol on the application layer. So you can see email, World Wide Web, WhatsApp, social networks, all in this green layer. In the following, let's have a look on one of these applications to understand the principles, how these works a little bit better. You all know and have used emails. So let's come up with a small history about emails, because it's interesting to understand some of the principles most of these Internet applications are based upon. History. Email goes back to the 70s. At this time, email were mostly used in academia. And at this point in time, emails were simply a text, where there was a common understanding the first line is the address. And then there was the idea to standardize emails. And in 1982 there was what is called an RFC, a ready for comment, which is basically a standard. An RFC 821 and 822, which described first the transfer of emails between computers and then the format of an email. 2 years later, the big CCITT came up with another standard, X400. And although this X400 was supported by big committees like CCITT, by countries and by big companies, we are using still the RFC 821 and 822. Why? Because those email has already grown up and has been widely accepted all over the world. And if you have now to go for CCIT X400, you cannot communicate with people who are using RFC 821 and 822. So if you're the only one who is using a better email like X400, you're still alone. So if you would like to go for a new standard, this one has to be backward compatible to not exclude all the other people who are using an old-fashioned standard already. This is an important lesson people have to learn. So you see it, for example, when you look on social networks. It's not maybe the best social network which took all the share. It was the one who was available right in time and got already a critical mass and could not be kicked away by others. So how does emails look like? Some of those things you know. An email address is composed of a name or a role, everything before this @ symbol, and then you have this @ symbol, and After that you have the domain, which often is composed of third-level domain, second-level domain, top-level domain. So you can easily identify your email at the FH Aachen in this concept. But there is more than just the email address. There is a way an email is composed of several parts. The first one is a to field, which is where you have to assign an email address. Here you have the primary receiver. Then you have fields like CC and BCC, which consist email addresses as well. Actually, CC stands for carbon copy, but what is carbon copy? Where does the name come from? In those times when you had typewriters and you wanted to have a copy, you put two papers of next to each other and squeeze the carbon paper in between. So when then writing in the typewriter, you not only created an original but directly this copy, which was simply called carbon copy. BCC is a carbon copy sent to somebody, but the primary receiver does not know that. And then you have from and sender. And actually, if you once again think about typewriters, there was actually maybe the boss and there was a secretary which really produced this letter. So you had to differ between the writer of the message and the real sender. The writer of the message is, let's say, the secretary, and the real sender is the boss. Nowadays, you do not distinguish anymore because you think everybody should write his own or her own emails. Finally, you have a subject. And basically these fields to, from and subject you know by each and every email you're sending or you're receiving. One problem has been at the very beginning that only ASCII characters could be used, but more characters were required. Once again, think about accents, non-Latin languages, and so on and so on. And actually, nowadays you can, for example, have emails with pictures inside. So how does this work if it's not supported by RFC 822? Actually, there's a new standard called MIME, Multi-Purpose Internet Mail Extension. And this is simply backward compatible. This makes it possible for MIME to become accepted all over. So MIME has a header, and if this MIME header is missing, the email program simply switches back to RFC 822. That's a simple principle to be backward compatible. And here you can see in the header what type of fields are available, the MIME version, the content description, and so on and so on. Emails not only have to have a message format, but there has to be one format to transport emails through the internet. And these formats are called protocol. And actually for email you need two protocols. The first one is from your email client to send it to your email server and forward it to the email server of the receiver. This protocol is called SMTP, Simple Mail Transfer Protocol. And actually the receiver has to request these emails from his mail server. And here other protocols are used. The most common one is IMAP followed by POP. So you can compare an email not really with a letter which is transported directly to your house or apartment. It's more like a service where it is transported, the email is transported to the next post office and you have to go there and request all your posts. Usually most of you are using simple email programs which are hosted in a browser. But if you use Outlook or Thunderbird or any other kind of professional email program, you have to specify, you have to configure it. For example, you have to enter your SMTP numbers and so on. Here you can, for example, see the IMAP addresses. For me, it's mailbox.fh-aachen.de. So you see it's a domain address. You have a certain port. I have a certain username. There is some kind of security and authentication method required, and so on and so on. So these kind of settings you have to do first before you can use your program. Actually, it means that you define within your computer to which mail server you are connected to. Let's have a look why Internet and its services are important for business. First, it's omnipresent. Internet is omnipresent. Internet is at every place in the world. It's at home and it's available all the time. So you're independent of time, independent of place. You can use Internet in the university, at home, in the pub, and you're independent of end-user devices. You can use it with a computer, with a cell phone, and so on. Just compare it, for example, with a bookstore in the city. The bookstore typically has opening times, so you cannot buy books after 8 o'clock in the evening. You have to go into the city to really get a book there. And you're simply dependent on the store. So it's by far not omnipresent. The Internet is global. The Internet does not stop at country borders. So you can build up business for not only for regional customers, but for customers all over the world. Maybe you have seen advertisements where, for example, agriculture in Greek are selling olive oil directly to the end customers in Germany. So this global world, if you talk about globalization, then it's only possible due to the fact that we have Internet. And hand in hand with global goes the following, the universal standard. If you go and travel with a laptop to the US or to China or to any other country, the Internet actually works in the same way. The most complicated thing is probably to get the power supply up and running, because this one is not standardized all over the world. But when it comes to TCP/IP and all the other services, it is. Internet is multimedial. That means it supports different types of formats: audio, text, video. So you can bundle different type of communications. If you compare it, for example, with a newspaper, then you have maybe pictures and text. If you have radio, you have only audio. But here in the Internet, you can combine all these means to a best possible way. Internet is interactive. If you think again about World Wide Web 2.0, it is that everybody can participate not only by reading but by writing comments. So it is important nowadays to each web shop to open up this kind of interactivity, to ask users to give feedback. People like that. And you can get additional value and increase the engagement of people within your web shop. So interactivity is a big plus. Compare it, for example, again to journals, radio, or TV. It's only possible in a limited extent. So you can ask people to give their feedback by calling in or by writing a letter. But not many people are doing so. So here, with this level of interactivity, you reach much more people in the Internet. Information density. As the networks have grown up and can transport more and more bits per second, more video and audio information can be transported. So the amount of information per second is increasing all the time. And last but not least, personalization. If you see nowadays TV or radio, then they're all sent to a big amount of people. Think about advertisements during a football game in the TV. It's not personalized, it's the same kind of message to each and everybody of the million spectators. If you compare it to internet, here you can track people, you can make profiles from people, and you can personalize, for example, advertisements to them. It's not only for a mass market. Even if you talk to millions of people, you can have millions of different advertisements. So personalization is one of the big issues in the internet when it comes to business. Let's have our third and last summary. A network without applications is useless. The internet gets exciting and attractive for its users due to these applications. Popular applications in the internet are, for example, email or World Wide Web. Many applications are based on the client-server model. You have seen you have email clients and email servers. So you do have browsers and web servers for World Wide Web. For many companies, the internet has become an important means for communication with the customers. And the following attributes of the internet are important for companies. The internet is omnipresent. It can be globally used. It's a universal standard. It's able to do personalization, so talk to different people in different ways. It is multimedia. That means it does not only use one thing like text. It uses text and pictures and audio and video. It is interactive and it has a high information density.